Good morning, students. Today on engineering mechanics, I am going to give lecture on friction. As you know, we have already discussed friction part in your physics level, and where we know that if two mechanical interlocking takes place in the two bodies, and they will give a opposing force while we try to move them, that is, you can call it a friction. Friction is nothing but a opposing force, and interlocking takes place like this. These are the mechanical interlocking. You can say this is the mechanical interlocking. If one body is like this, another body will be like this, and if you try to push or pull our body, and you will find an opposing force here due to mechanical interlocking, which is called as a friction. Generally, we denote friction as a F, small f, friction, and we have a different types of friction are there. One friction is called as a sliding friction. One is called sliding friction. Another one is called as a rolling friction, limiting friction. Another is called as a limiting friction, and core friction. These are the different types of friction. And one more friction is called as a dry friction and fluid friction. These are the different type of friction force we generally get. What is sliding friction? Now, when one body slides over another body, there is two flat surfaces are there. Like this is one flat surface, or on a table. If we put a duster and if we give some force, then this duster will slide over this table, and that type of friction is called as a sliding friction. And when one body rolls over another body, that is, there is on a table, if we put a ball here, and if that ball will start rolling over the table, whatever the frictional force developed, that is called as a rolling friction. And what is limiting friction? Now, limiting friction generally it comes like this. If we plot a graph versus force versus frictional force, like this is our frictional force and this is our force, and when we try to move a force, like there is a body having weight of 50 Newton, and this is the plane, and we supply some force. That force equal to how much it is? 40 Newton force. If we supply 40 Newton force, the body can move. So now we increase the force. Again we increase the force. When it reaches 50 Newton, when applied force is 50 Newton, and the body weight is 50 Newton, now the body is about to motion. So if you plot a graph like this, means it is 50 Newton and the frictional force is 50 Newton, because the internal force, due to internal force, it will reach here. Then if we supply 50.5 or 51 Newton force, then the body will start getting motion. That means frictional force remain constant. So that such friction is called as a limiting friction. Means the frictional force at which body is about to get motion is called as a limiting friction. Then it is cone friction. And before going to cone friction, we should know the different laws of friction. What are the different laws of friction? Now, the frictional force is directly proportional to applied or normal developed by the body. Frictional force is directly proportional to normal developed by the body. What is normal developed by the body? So, before to know the normal developed by the body, we should know the free body diagram of the friction. So, what is the free body diagram of friction? Like this is a plane where the body is placed. This is a body, and if we apply the force, like force here, let frictional force always at lower opposite direction of motion, that is F, and this is your normal. Always frictional force and the normal are perpendicular to each other. So this is the normal. So according to laws of friction, the frictional force is always directly proportional to M. So frictional force equal to how much it is? Mu into M, where mu equal to where V equal to coefficient of friction. Coefficient of friction. mu equal to coefficient of friction. So this is the first law. And what is the second law? For a low velocity, frictional force is negligible, because as we know, for low velocity, frictional force is negligible, and the frictional force is directly proportional to normal of the body. These are the two laws. And the third law is what? Now, the frictional force is always independent from the area of the contact. That is the third law of friction. Frictional force is independent of the area of the contact. So let's friction. How you understand that frictional force is independent from area of the contact? That we consider here. This is a plane, and this is the surface where the plane is contacted. And if you draw the free body diagram, where a force we are applying the force here, and the normal. This is the frictional force mu n, and this is your normal. Now, if a body position is like this is the position of a body, and this is the plane. And similarly, if we draw the free body diagram, the frictional force, this is the frictional force, and this is the normal. Where frictional force is the base for the theory or formula equal to mu n. So the normal is constant, and here normal is constant, and the coefficient of friction is depends upon the material. What are the material? For the different material, different coefficient of friction are there. So frictional force is equal to mu n. So it is independent from the area of contact. Thank you.